Hello. Welcome to What's New in CLDR and ICU. I'm Anne Marie, and
I need to turn myself on. My name is Marcus Scherer.
do we need to get you a microphone?
Not yet.
And of course, Mark Davis. So first we're going to go through what's new in CLDR in the last two releases. So since last time we had UTW, the CLDR 45 released and CLDR 46 will release this week. So at kind of a high level, we migrated the site. There's been spec additions, locale coverage has increased. There were updates to Unicode, the message format, tech preview, and then the emoji search. So one of the big things that actually happened is we finally migrated the CLDR site to Markdown. I'm starting at the bottom. This makes me really, really happy because now we'll have version history on why we made all our changes, right? And we can go back and look at it. So this makes me really, really happy. It's also in a lot of ways pretty. And I don't know if we can click through this. We were going to click through this. I guess.
Expand the window.
Okay, let me expand. So we've got this pretty new site here. We've got the nice nav bar. You can click through and go to a bunch of our stuff. We have the releases and downloads. Feel free to play around with it and let us know if you do run into anything unexpected. Let me know if I'm too quiet too. So I am. You're good. I don't know. He talked about.
Escape.
I am hitting escape. It does.
Oh, your full window on that. Nope. There.
It did not like me. Wait. This is not my computer. Oh, it's got the hidden.
Yeah, I hide things. Yeah.
Oh, this is not how mine is set up. So, okay. So that's kind of the exciting thing. If you want, there's a whole site map that you can click through. The other thing is there were two major spec additions. The LDML conformance. So there's still more work to do on that. And then the semantic skeletons, which there's a whole nother talk about. We also regularized a bunch of the links in the spec. So for example, you can come here and then, you can come up here and come in and say dev. And anyway, you can click through them. It's fun. So back here. So next, we had a lot of languages which were up-leveled. So now we have 97 at modern, 16 at moderate, and 55 at basic. A lot of that was due to the efforts of the DDL work group, the Digitally Disadvantaged Language Work Group. And here's kind of a breakout of which languages advanced. Hey, I went fast.
That did go fast. We have lots of time for questions.
That was it.
No, it keeps going, but that's the end of it.
Yeah, for message format, you'll really want to see Addison's talk, but basically message format 2.0 is a new version message format that adds a slew of capabilities and is far, far more extensible than what we had in the past. The definition is in CLDR, but the implementations are in ICU for J, ICU for X, and will be in, ICU for J, ICU for C, and will be in ICU for X at a tech preview level. So in 45, we added the modern internationalization capabilities, dates, numbers, genders, and so on. Extensibility to allow for things like date-time intervals, grammatical agreement, and the data model, which allows for incremental migration of users. So people can translate to the data model and then generate message format 1.0 versions. The Tech Preview 2 is removing actually all of the reserved and private use syntax constructs. These, you might say, well, what the heck is that? It had a lot of mechanism to allow it to be forward compatible. But forward compatibility is not typically a requirement for specifications because you want to allow the capability to add new mechanisms in the future. And it's okay as long as you maintain backwards compatibility, which means all the old messages continue to work. So the structure was jettisoned because it really didn't accomplish what was necessary, and it simplified the grammar dramatically. Changed the structure of the match selector so that it required the use of local input declarations, and then it added support for bidirectional islets. And what that allows people to do is construct messages so that you can put bidirectional controls in the white space between certain syntax components so that the message can display properly to BiDi users. Because otherwise, as we know, when you've got a mixture of Latin characters and punctuation characters and Arabic characters, and you're trying to read it, it's an unholy mess. So by allowing people to put in that allows them to make their messages readable to people who are just looking at it in a plain text environment. And the final candidate is planned for 46.1. And 46.1 we're planning for before the end of the year, but then with review and so forth, and then coming out in the 47 timeframe. So that's where we'll first see it in implementations, and Marcus is going to say a little bit more about that. Right, Marcus? Sure. And for more on message format, as I say, see Edison's discussion. He has very good discussion of what it does, why we're doing it. Unicode 16 also made a number of changes, and there are two big ones. One is that the Unicode standard has always provided an associated standard for collation, which provides a collation sequence for every single Unicode character, all 150,000 of them. And we have modified that for what's called the CLDR root collation, which is what all of our locales inherit from. So when you were using CLDR, you were using a somewhat modified version of that original one, plus whatever locale rules were special for, say, Swedish. And then that was what was used in ICU. And Marcus spearheaded the effort to get these to align. And one of the purposes for the CLDR collation was to semantically group certain collections of characters so that developers could override the position. And this is needed for certain standards. I think Danish, for example, where you want to sort digits after letters instead of before. So you want to be able to take these chunks of things and say, well, I'm doing an index for Russian, so I'm going to put all the Cyrillic things before all the Latin things occur. So this capability exists, and it was put into CLDR to enable that. Marcus was able to get agreement by everyone to rationalize it, changing mostly the Unicode base set, but making a couple changes in CLDR, which are listed here. The non-decimal digit numeric characters, like Roman numerals, I guess, now sort after the decimal digits. There's no tailoring of the currency symbols. So if you get a real that's based upon a sequence of Arabic letters into a chunk, then it sorts as if it were the sequence of Arabic characters. And then almost all other regular characters sort the same. There's also an improved Han radical stroke order. CLDR was using an older version that didn't match what's defined in the Unicode Standard Annex number 38. And so we've updated to that, and that changes the way that the residual strokes versus the traditional simplified versions appear, the ordering of them. As with everything, you have to re-index. If you're using indexes that are built upon sort keys, whenever collation changes, you have to rebuild the index in your database, because otherwise it's just not going to make any sense. It's not going to work. Now we do that. We tell people that each time, but it's especially important for a case like this because of so many shifts. Emoji search keywords. Thanks to Meta, we took on a whole slew of WhatsApp emoji search keywords. These were, oops, looks like a typo, which were reviewed and then by all of our vetters for 100-ish languages, and then and combined with overlaps removed and so forth. We also simplified the keywords and increased the maximum number of keywords so that you take something like white waving flag. We used to have like white waving flag and waving flag, and now it's just white and waving and flag, because we really don't care what the order that you type these in, and we don't want to miss something because you happen to type change the order or something like that. It was much simpler to just use the individual keywords. We also, for the vetters, clarified the usage model, which is I'm going to type in a word that'll narrow the field, probably see it. I type in another word, it narrows it more, and then I can pick it. And to make sure that everyone was aligned with what the usage model would be. And we also, there are a couple other criteria in there, but those were the big ones that we used. So I'll turn it over to ICU, and if you go as fast as we did, then we'll have plenty of time for questions.
So you want me to speak really slowly? Well, let's see what I can do with that. Do we have a little laser pointer thing? Look at that. That lets me point, and the pointing should end up in a recording rather than me walking to the projection here. So we release CLDR typically twice a year. We also release ICU typically twice a year. I should be fine with it. Yes, I'm wired. Look at that. We actually release ICU and CLDR nearly on the same day. Sometimes we are a day or two off. But as a result, we do different types of work all in the same release. Maybe I should take this one down here. We update to the latest version of Unicode together with some other standards like currency codes and time zones and things like that. We also update to the latest version of CLDR, which then happens to be the one that is actually released on the same day or day before. And then we do maintenance work like fixing bugs in ICU and making sure that we plug holes and other kinds of things, and update to new versions of C++ and Java and all those kinds of things. And then we do feature work, and sometimes they intertwined. So here I have a bit of a list of things that are changes that have kind of come in from Unicode and ended up in ICU in the last year. The first thing is that, of course, we have Unicode 16 now. We have, what, 5,000 or so new characters. Among them, we have several modern use scripts. Believe it or not, they're actually scripts we don't have encoded yet that people today actively use rather than things that are ancient history or scholarly use or technical use or something like that. So these are the 5 modern use scripts. We also have actually a couple of ancient scripts. We have almost 4,000 Egyptian hieroglyph characters. They're supported with all of the property data in ICU. At this point, maybe since we have time, we can also briefly say, who cares about Egyptian hieroglyphs or something like that? Most people don't really need to use them in their daily lives, but Unicode really has a mission to support all the characters that people need for some purpose and reason. And in this case, it allows scholars to exchange actual text and search through text and find text rather than looking at images and trying to figure out what the old writing system had. One level up, of course, we have changes and adjustments whenever the Unicode algorithms change. We have to look at our implementations because we implement those algorithms sometimes with CLDR tailorings, modifications, but generally based on what Unicode has. And some of us are actually working on both sides, on the Unicode level as well as on the ICU level, and we feed on each other and make sure on one hand that the standard provides what people need, on the other hand that it's also implementable and that it reflects reality and everything. With that, actually, CLDR and ICU are sometimes ahead of Unicode, when Unicode has given us generally a mandate to say, okay, this seems like a good idea. Why don't you try it out, bring it into products, see what happens. If it actually improves things, then yes, let's change the Unicode spec itself. And sometimes that then happens 1, 2, 3 years later. And we've had a couple of things that we did sort of ahead of Unicode that that Unicode then caught up to. We've also had a couple of things where ICU needed to follow up on a couple of changes that happened in Unicode land. So we are nearly aligned. We actually found that we missed one thing for word break that we have to then update in the next version of ICU. But the line breaking changes that we have made were upstreamed into Unicode, and those changes worked out well. ICU supports most of the Unicode properties with APIs, so you can ask if a character is uppercase or lowercase, what digit value it has, and all kinds of things. There's something like 100 properties that we support. We don't support most of the CJK character properties. A lot of them are really cross-references for the people doing the encoding work. There are a couple of things that might be interesting, but it's also a very large set of data that we don't carry. But we do have new data, for example, for dealing with usernames and domain names that let you say, okay, Unicode says these are the characters that you should have in those kinds of identifiers. And these are the ones that are not, but maybe some subcategories for certain reasons you might want to include anyway. And so now you can do that programmatically. And a couple others for some more specialized things. On the Unicode side, we also had a change in how we do some of the international domain name processing, and that got reflected in ICU. And in sort of the early testing in products, we found that actually people were looking at, well, is this a disallowed or valid character? And notice some changes. So we have more characters that are valid beyond the ones that are new in Unicode. Some of the ones that have long been forbidden because they work differently from an old version of that standard. That old version of the standard is long obsolete. We've cut ties with that. More things now work, including Georgian capital letters. Some Georgian people might be happy. Mark talked about collation. ICU does sorting of strings or comparing of strings for sorting based on the collation data from CLDR, which is now almost the same, very nearly the same as from Unicode. We also have other things like the alphabetic index and the string search APIs built on top of that. Then we have message format 2. We had a tech preview implementation, an early version in Java a year ago. That has been updated to something very recent. We've got a contribution from someone who's worked with us intensely over the last year to get a C++ implementation into the spring release, and now also updated for the fall release. And Java and C++ are fairly close to each other now. And as the CLDR version of the message format spec should hopefully get a final version by the end of the year. Around that time, we hope that we also have a version of the ICU code up to date. We're not planning for an actual release because for us, that's a heavier process when new API is involved or API changes are involved. We probably will have a snapshot that people can download, not a formal release. And then the actual release in March would reflect the final version of message format 2 in both C++ and Java. Were you looking for something additional to that?
Oh, I just want to acknowledge Mihai, because doing an implementation while a spec is changing is no fun at all.
Yeah, and also to Tim Chevalier on the C++ side. So we've had some changes kind of under the hood. ICU actually, maybe I should tell a little bit about ICU. ICU started as a project in the mid-90s, became an IBM project in 98, fully IBM, became open source in 1999. And in the initial days was called the IBM classes for Unicode. Then starting 2000 or so, we call it the international components for Unicode. Partly to generalize away from just IBM because it had become open source, partly because it wasn't just classes, because we also have a C API, we still do. Since we started in the 90s, we of course relied on very, very old versions of C, C++, and Java. And so every few years we update, not to the latest and greatest, because then we would leave a lot of our users behind. But sometimes we just have to update a bit so that we can take advantage of new language features, use standard library features, and actually then also make our lives easier. But also if we just adhere to old versions of the standard, oftentimes that would force us into things that modern versions of the standard have deprecated and don't even want us to do anymore. So we have upgraded to relatively recent versions of C++ and C. Previously, a year ago, we also moved up to all the way to Java 8 on the Java side. We still have a constraint for people running on Android, for example. So we have a Java version that is supported roughly on relatively old Android systems. And then the third bullet here is about internal improvements in memory management and stuff like that. We have thought about ways of making ICU easier to use in a modern language world. Some of our constructs are fairly old-fashioned and no longer how you do things as a programmer. And by moving up to C++ 17, for example, we could take advantage of something called a string view. Probably not a lot of people are really into C++, but maybe for the recording. In the C++ standard, it's been a bit of a messy evolution of which data types you use to represent Unicode. And even if you settle on either UTF-8 or UTF-16, there are different data types that you could use. C++ 17 added this construct of a string view, which combines basically here are the characters and here's the length, but doesn't own it. And that is really good for input parameters, really good for efficiency and just working with different parts of the standard library. We weren't natively supporting that before with our own string class and our other APIs. And so we created a bit of a bridge now with our string class called Unicode string, so that you can easily go back and forth and use standard library string classes more easily and with more performance in some cases. We also thought about, well, how can we make your lives easier for using a correlator in a Unicode set? The correlator is the thing that you use for sorting strings, but how do you sort strings? You have to basically have a sorting algorithm and then pairwise compare two strings. Now, there is a sorting implementation built into the standard library. And you can call the standard sort thing on a standard container like a vector of strings. But then the question is, well, how do I hook that up to an ICU correlator which compares two strings? And the answer is in the C++, in the modern C++ world, it wants you to have an object that says, well, it's true if the left thing is less than the right thing, for example. And you could previously already write some glue code to make that happen. In this case, with the new API, you just say, well, given the correlator, give me the less than thing of the correlator, stick it into the standard library function, and it just magically works. There's a little extra boilerplate here for creating the locale object that says trying to get Swedish sorting, then get the correlator for the Swedish sorting. But then the rest is just very normal C++ code. You have a collection of strings, you have the sort algorithm, and you give it the thing that says, well, do the alphabetic sorting. If you want it in the other way, you can say greater instead of less. Similarly, we have had a Unicode set for a very long time. That probably already existed 25 years ago, but we had our own way of iterating over it. If you want to say, loop over all the characters in the set, or loop over all of the contiguous ranges of characters in the set, you had to figure out from our API docs, yeah, there's this other thing that is this iterator kind of stuff in C++. You create an object from that and then call next and other things. Or in C, you have to say, okay, give me the number of ranges and then give me the first, the second, the third, the fourth range, and do something with it. Well, modern C++ developers expect there to be some way of doing a for loop where you say for value in the container, and you expect it to magically work. And now we have an API to make that magically work. So here's an example for, well, we have a set with a few interesting characters, and you easily get, in this case, the ranges. We have other APIs to get you just the code points or the multi-character strings and stuff like that. We would really like for our users to bang on these new APIs a bit and try them out, partly because we also came up with another new idea. Some of these things can be applied on the C API. The C API is often particularly useful because it's binary stable. And that means that you can update the ICU shared library or DLL without having to recompile the rest of the program. And it will call the same functions with equivalent functionality. But C++ doesn't really allow you to support binary stability. These new APIs are completely in the header. So you can compile it against the C API from ICU and it will work. But you can still use nice C++ to actually do this stuff. And we have a bit of an isolation between the caller and ICU itself so that we don't get into trouble with that. So we would really like for people to try that out. It doesn't now let me, maybe I have to click this thing. On the Java side, we've also made related work. Maybe I should talk about the second bullet first. We have similar things for the Java version of Unicode set. We have always had easy ways to iterate over things, except for single code points. We added that, or single characters. That's almost the same term. But also since Java 8, and now that we can use Java 8, a lot of Java programming is using stream interfaces. And so we also added stream interfaces to Unicode sets so that it's easy to go over the dozens or thousands of characters and strings in a Unicode set. We've had a bit of performance work. We've had other bug fixes, of course. We always do a fair amount of improving things that are not very visible. One of our contributors was particularly interested in getting these kind of things to work well for places where there is caching and startup costs. And then I have a slide that is actually not really me. Maybe Mark wants to talk about that one again.
Sure.
Do we otherwise have an ICU for X? Maybe Elango wants to talk about this.
Okay. Yes, doing it cold. Yeah, one way to get percentage.
Yes. So
We
yeah.
have to do more of that.
Well,
Yeah.
ICU for X has been working really hard and making a lot of improvements. So there's a whole new revamped datetime component. So the APIs have changed, and also the semantic skeletons, which is to pick out sets of datetime fields that actually go together, because there are a lot of combinations of datetime fields that don't actually make sense. They just don't work. So that's what semantic skeletons is about. So it's a bit of pushing the envelope or pioneering in that way. So there's more idiomatic binding. So that's work with Diplomat to make sure that we can support namespaces, for example. Also pulling the latest versions of CLDR data and Unicode data. So just like ICU does. We have unit and currency formatting, and improvements, as always, to performance and size, which is one of the few, there are multiple important value propositions that ICU for X provides, but performance and size is one of them, so that it can continue to go in places that can't yet be, can't be served by ICU, but ICU for X can go there. Over to you.
Yeah, I'll mention one other thing for people that aren't acquainted with ICU for X. By bindings, one real advantage of ICU for X that we've long struggled with ICU is we have to write everything twice in C and in C++ and in Java. And one thing that ICU for X does, it provides a really easy way to bind other languages, so that you can access ICU for X from C++, from JavaScript, from Dart, and from other languages. It's a system that's called Diplomat. And it might be worth some time just giving a whole talk on that, because it's really, oh, there is one tomorrow. Okay. Well, so I think we're done, and we can, again, thank our organizational members, but why don't we just have answer some questions? Unless we've stunned everyone into silence.
This is your chance to ask anything to the people who are responsible for all your joys and pains.
And pain.
This is Aniket. I work in Coupa software. So as I understand, ICU is implemented in C++ and Java, ICU libraries. And so at Coupa, we have a Ruby on Rails stack. And my understanding is that for text stacks that are not Java or C++, I think we have to look out for some open source libraries, or someone has implemented something for ICU. So my question is, do you guys keep track of these other libraries in other languages? Or do you usually have recommendations for like people that don't use Java, that don't have Java or C++ in their stack?
Why don't you take that?
So in the old world where we got started in the 90s and early 2000s, basically the idea was that we would provide C++, Java, and then other projects would develop wrappers in some cases. For example, there is a really popular Python wrapper that's called PyICU, and it wraps the C++ version of ICU and exposes almost the entire API surface. So for Python developers who can bind with PyICU against the ICU4C version, that is a pretty good and popular solution. There used to also be some other wrappers for other languages, but they tended to be one-offs and tended to not be maintained. PyICU actually, the current version of the PyICU code already supports the version of ICU that we're going to release tomorrow or on Thursday. So PyICU is really up there. But yes, there has been a gap because not a lot of other people have done that kind of work. And there is a fair bit of mechanical, not very interesting work in developing this kind of wrapper. The newer idea with ICU4X is that there's one implementation where the generation of the wrapper, this diplomat kind of layer, is mostly automated. There's instrumentation on the Rust code side to drive that a bit in certain directions, and then it generates the wrappers. I think there's not a totally clear solution, I might be wrong, for exactly what that means for Java, because the J and I transition is fairly slow. So that's a bit of a hurdle, but for compiled languages, that is probably a reasonable idea. And also one of the things that you can one of the things you can do is you can recompile the Rust code for ICU4X into WebAssembly and adapt that into JavaScript kind of stuff. So that kind of thing works in a way by basically starting from scratch and doing a lot of things in a totally new world on a totally new basis. ICU4X managed to take advantage of new technologies that we didn't have 25 years ago and develop some of these kind of things. So now we have sort of the old libraries, the new libraries. They both do a lot of the same kind of things, but they are in slightly different usage scenarios at this point.
Yeah, just to add on to that real quick, there are a few motivating reasons for ICU4X. I think of the leader among equals, and those reasons is being able to write code once to create new features or maintain new features and have it support multiple programming languages with that just the constant time effort without having to have, if you're supporting Dart and Flutter and Ruby, for example, would you have to have 3 people or 3 times as much work as you would do for just one of them? So to be able to do work once and have it kind of transpile is kind of like the original motivating reason, but then the other reasons why ICU4X exists are also important. So the idea is if you want a new programming language, and if you know a bit of Rust to add support for the language of interest, Ruby, for example, then you go into Diplomat and then you say, this is how I want the annotations and the Diplomat annotations that are being added to the ICU4X APIs. This is how I want that to convert so that it looks like the Ruby that I know and love. So if somebody goes in there and does that once, then in theory, then you're done. And so what actually happened is that someone has done that or was trying to do that for C#. Someone is doing that for Kotlin. And these are open source contributions. That's great. It's not the main contributors to ICU4X and Diplomat who've done that. And now you can benefit if you're using Kotlin and C#, and so can they, which is pretty cool.
I'll mention one other thing is when you make various calls to Windows or the Android OS or iPhone or Mac or lots of other operating systems, you're really calling ICU under the covers. So they're providing a shim that that ends up calling ICU. Another question? Conrad, you look like you have a question.
I always do, yes.
I don't have like actual coworkers, so like you're all my coworkers. Okay, so the thing that's been bothering me, one of many, is
Just one?
well, like while I'm in the DDL group, I'm like oh, like the how do we like pitch CLDR to communities? And it's very focused on getting Excel spreadsheets to work in the language. And there are many other things that people need in these different communities. And I'm like, what can we do in the Unicode to provide that? And like, because I don't ever want to say the Unicode mission is over. Like, are we just in a stage where we're just optimizing what we already have? Or like, what are the inflection points that Unicode can like drive in the industry? Like I said, that was a big question, but I think you can get it.
Yeah. Well, let me, yeah. Well, let me just say one thing is the focus is not just spreadsheets. That's an example. But one of the things we did was we went through a typical sort of suite of Office software to see which things are needed to support the Office software. And that's where we came up with a list, which is listed in the modern section for what people need. So that's something that we can change over time. But if it's different kinds of things you're looking for, like spell check data, then that's something that would be just a whole different project that we'd have to take on and look at. But part of it would be to help to define what is really the next step for DDL community. And I think that depends upon kind of the status of the DDL community. You know, if people are more concerned, if it's a small community, then Office software is not a particular target. If it's a larger, I mean, if it's a 1 million person, DDL community, that's a bit different. 1 million to 10 million person, then it's very likely that people would want to, create spreadsheets, create documents, create newsletters, newspapers, all sorts of things that really do need that level of support.
Thank you. And I guess to involve Marcus and Anne-Marie, I'm going to re-ask the question, but in a different way. What has Google done by itself that because there's something I think of as like when we ask to submit the data in Unicode for CLDR, it's all like the very fundamental stuff, but it's not going to get their language actually in the interface. There's a lot of translations that you and Google need to do that aren't part of CLDR at all. Like, what would Google want to move into CLDR? Like you already like of course Google like ICU is almost a child of Google at this point, but sorry, it's contributed by many people. Google, thank you so much for your contributions. But like what are other things that like Google would want to offload into Unicode that is currently being held in Google? So like I don't know.
I don't think we have actually a lot on this kind of level that is not open source. Google does contribute a fair bit to ICU. We also have Apple, of course, as a big contributor. We used to have more contributions from IBM and Microsoft. We also get a lot of individual contributions. But actually, ICU is at the core of Google ITN. It's not the only thing, but it's a very large part. We've also done some other work like phone numbers and address formatting and things like that. We have, as a company, open sourced those not into ICU, but as separate projects, but they're open source and available. We've got something internally to sort of have nicer handling of language codes, language tags, but that's not really so much beyond ICU and CLDR that there are fancy secrets and things that would make a big dent. There have been other kinds of efforts where CLDR has taken on person name formatting, for example. CLDR has added various other things. Don't forget that Unicode itself has a standard for collation, sorting, searching, has a standard for domain names, has various other standards, and ICU actually does implement those. So a lot of those kind of things are covered, and sort of the higher level stuff in Unicode, we've had discussions for, well, what do we do about machine learning, collecting data, doing sort of more linguistic stuff. Those are fairly hard things to do. But there's a lot of licensing issues. There's a lot of how would we collect the data effectively with a small volunteer organization. What are the costs? What are the benefits? Who would be using exactly that data? When something crystallizes like person names and message formatting, then that can become a working group, and maybe some things remain outside of what we do for a longer time.
Yeah, I'd take an example as inflation. In fact, inflections.
Let's solve inflation.
Yeah, let's solve inflation. Yes, yes. Yeah, well, win the election. For inflections, it's that arose out of ideas that people exchanged in this group last year, and so there are. I think there are a lot of things that could be done, but part of it is identifying where the best return on investment is. What would benefit if you're looking at DDL support. What would be the best next thing that people could use that would enable their language in particular areas? And I think something tells me that Anne-Marie has one of those.
Well, I have the one that always just comes up in debate, right? About how we decide whether to include more languages in modern coverage that aren't necessarily at basic level. And this one this one has been revisited for discussion several times, and we will probably revisit again this next release.
Yeah.
And that one is very, very DDL specific, right?
I'm getting nudged by the organizers
Okay.
for wrapping up this particular session.
Shall I stop recording?
Well, first we should give you a hand.
Okay. Well, I cleverly waited to stop recording until after the clapping.